Welcome class, today we'll be talking about Taxicab Geometry. It's actually an extension, and it makes sense to talk about it when we're talking about like streets and maybe driving a taxicab. Um, I've also seen some games played using Taxicab Geometry. Uh, they're more of like a Go type game or reversey, but we could talk about that later. Alright, so one of the goals here, you apply geometry to real world problems. The first thing, the distance between 2 points is the sum of the difference in their coordinates. That's the taxicab distance. If I look here, it's going to be the horizontal line plus the vertical line. That's pretty much it, the lengths of those. So I'm basically counting up the squares. Yeah, this is the official formula. If you look at the distance formula, which is still behind me from the last problem, all it's missing is the square root and the squares. They're not counting the length between the 2 points, which is the shortest distance. What they're doing is they're taking the horizontal distance plus the vertical distance. They're calling that the taxicab distance. Here's the official formula, but it's the length of the horizontal plus the length of the vertical. Example 1 here. Find the taxicab distance from A being -1, 5 right here, and B being 4, 2, and draw two different shortest paths from A to B. Well, the first one is the simple one. Straight across, straight down. Shortest distance. 5 to the right, 3 down. The next choice might be a path like this. It's still the shortest. 2 down, 4 to the right, 1 down, 1 right. Either way, when I do this problem, I'll plug it in 4 minus -1. x2 minus x1, absolute value, plus y2 minus y1, absolute value. Simplifying, I get 4 minus -1, which becomes 5, 2 minus 5, which becomes -3, and now I just take the absolute value, 5 plus 3, 8. Both of these are the shortest distance, even though one you have to turn more. That's it. That's example 1. The distance is just the horizontal plus the vertical distance. The next thing we want to talk about is taxicab circles. Even though they look like taxicab diamonds, we're going to call them taxicab circles. And these are circles that are the same distance from the center. So an example of a taxicab circle with a radius of 3 would look like this. To get to this point up here, I would have to go 3 marks straight up. To get to 1, 2, I'd go 1 to the right, 2 vertical. 2 to the right, 1 vertical, or 3 to the right. Yeah, this is called a taxicab circle. I realize it looks like a diamond, okay? But that is a taxicab circle. You could overlap different taxicab circles to find out which points are actually the same exact distance from two different coordinates using streets. This is a little bit more applicable in bigger city areas or something that have roughly the same size blocks. And at this point, you should be able to use the taxicab geometry to find the block distance between 2 points. I know this is a short section, but it is also a short section. It's also worth the least amount of points, so I don't feel bad going over this very little. If you have more questions, feel free to ask me, but basically you're just counting the number of blocks you have to go somewhere. The shortest distance doesn't have to be straight horizontal and straight vertical. It can be a weird path. However, it should be the same length as going straight horizontal and straight vertical. That's it. Until next time.